Hi guys, and welcome to Activity 2 of Physical Sciences for Year 9. In this activity we're going to be looking at the concept of conduction. Now basically what we need to understand is there are three ways in which heat energy can move, and that's by conduction, convection and radiation. And including this activity, the next two activities will look at the convection and we'll also look at radiation. But the question is, how is the heat energy able to move? Now the idea all comes down to the concept of particle theory. We're aware that all materials are made up of atoms. Now those atoms, as they are placed together, come in three main states of matter. There's solid, there's liquid, and there's gas. This diagram here shows us the three main types or three main states of matter. We've got solid on the left, liquid in the middle, and gas on the end. So how does the energy link with these different types of particles? Well, if we look at a solid is made up of atoms which are tightly packed together. Now, even though they're tightly packed, they are vibrating, and they're vibrating because they have a certain amount of energy. Now, this vibration produces friction. This friction generates energy. So if you've got something which is really, really solid, all you've got to understand is that the atoms are just moving very, very slowly. Now, if you increase the amount of energy, the amount of heat energy that you apply to those particles, what will happen is their movement will increase. As they increase, the gaps between their partners also increases, which means that you then get the concept of a metal or a solid expanding as it heats up. This is shown really, really well in the case of a metal. Eventually you get to a point where the bonds holding the atoms, the vibration of those atoms is so great that the bonds almost become jelly-like. And as soon as they become jelly-like, we then go into a liquid state. Now, the point at which this happens we call the melting point. This is the point where the atoms are able to then slide over each other. Now, each different material will have its own specific melting point. Why? Because basically the atoms are held together with different strengths. So depending on the type of material you've got will depend how much energy will need to be required to vibrate the particles so that the bonds allow you to slide over each other. So a liquid state basically is the point where the particles have got enough energy so that they can slide over each other. They're still in contact, but they can slide over each other, and it gives the concept of being able to flow. So you keep heating up the liquid, and you heat up the liquid, and you heat up the liquid, and these particles are getting more and more vibrational energy until eventually their vibrational energy is so great that the bonds are able to break. The bonds holding those atoms are able to break apart. At this point, we call this the boiling point, and this is where a liquid will then change state into a gas. Now, in a gas state, the particles now have enough energy or vibrational energy to break away from their neighbours, and then as a result they can move randomly throughout an environment, whether it be an enclosed room or the atmosphere. So we basically look at the concept of states of matter, each being down to the fact that the atoms have a certain amount of heat energy or energy, vibrational energy. Points where they change from one state to another we either call the melting point or the boiling point. Now obviously, depending on the type of atoms we've got, heat energy is able to move through that material. And you've really got like a domino effect. If you heat one end of a metal object, what will happen is the vibrational energy from those atoms at the end will pass on to the next one, and then pass on to the next one, and then pass on to the next one. The speed at which that happens talks about how well heat is able to move. Now, when we look at conduction, basically we find that conduction is a transfer process that only occurs in solids because we've got the particles very, very close together. If you are able to move heat very, very easily, you are called a conductor. If you're not, because the particles are either too far apart or they're held too tightly, you've got the opposite, which is an insulator. So a conductor basically is a material that allows heat energy to flow through very easily, whereas an insulator is a material that only allows the heat energy to move very, very slowly, if not at all. A good example of a heat insulator would be something like wood. Wood is a good one. You try and burn a stick, you can burn the end, yet you can hold the end of the stick and you don't feel it. You get a metal teaspoon, you heat the end of a metal teaspoon and then hold the end, you'll find that heat will move through. Okay, so how does that happen? Let's try and explain this concept of conduction. So let's look at this diagram here. Basically what we've got is a Bunsen burner heating a material. Now you can see in the diagram here the direction of heat flow is from left to right. So basically what happens is the particles at the Bunsen end are vibrating a lot, okay? Not enough to break apart, not enough to cause them to flow over each other as they turn into a liquid, but they're still vibrating. And what happens as they vibrate, they're knocking into each other. As they knock into each other, they're passing that heat energy down the line. And what you see is this continuum going from, in this case, left to right, with high heat energy at one end to low heat energy at the other. And this follows what we talked about in the last activity, that heat will flow from high energy to low energy. So as a result, what we get is this domino effect as it passes through the material until eventually we feel it at the end in our hand. Okay, so what I've done is I've put an explanation here for you to make some notes on. I would pause it here so that you can actually read what's been written down here, and then you can make some notes. So if you pause it now, you can go through the explanation. Okay, so I hope that basically explains how conduction works. Remember, only occurs in solids, and it's down to the particles having vibrational energy. You increase the heat energy, you increase the vibrational energy, and they pass on down the line. Okay, so what I would like you to do is have a go at the exercises on activity 2B, and hopefully that will consolidate what we've talked about in this conduction activity. Also, have a look at the practicals which I'm going to be posting up, and hopefully that will also explain what's happening with respect to conductivity. It will also talk about the various, how different materials are able to conduct heat at different amounts. Okay, thanks for watching, and I look forward to joining you again.